Hey guys, welcome. Part 3 is underway, and let's start with our first problem, number 46. And what we are doing is we are solving, finding all the solutions for this. So x plus 4 and the square root equals 3. To get rid of that square root, we're going to square both sides. That comes x plus 4 equals 9, and then x will equal 5. Okay, we can check it by plugging it back in, and it would work. 47, again the square root of 3x minus 2 equals 4 minus x. So we're going to square root both sides, and this is going to become 3x minus 2. Over here we're going to have to FOIL negative x, so basically we can get rid of the squared and we're going to get 4 minus x, so we can go ahead and FOIL that. 4 times 4 is 16. 4 times negative x is negative 4x, and you're going to get that again, and then a positive x squared. So we wind up with x squared minus 8x, and then plus 16. We're going to move these over here, so I'm adding 2 over here, and I'm subtracting 3x to give me this. Now I want to see if I can factor that. Two numbers that multiply to 18 but add to a negative 11. I believe that's going to be negative 9 and negative 2. So x minus 9, x minus 2, which means x is going to equal 9 and 2. They're the opposites, and we have a simple one like that. Okay? Alright, moving to 48. We haven't seen a problem like this in a long time. These are absolute value equations. And what we do here is we basically set up two cases, if you guys recall, case 1, case 2. Case 1 is 2x plus 3 equals 7, so you basically just write exactly what you see. And case 2, you do the same thing except for instead of a positive 7, a negative 7. If this whole thing was negative 7, and we took the absolute value, it still equals 7, so we get two different cases. So we just algebraically solve these, subtract 3, we get 2x equals 4, x equals 2. Or over here, we subtract 3 to get 10, divide by negative 10, divide by 2, and we get x equals negative 5. So either one of those two equations would reach us our answer. Okay. 49. Again, we got the same situation, x squared minus 3x equals 2x. Okay, so we do our case 1 and case 2. So x squared minus 3 equals 2x, and then over here we're going to get x squared and minus 3 equals a negative 2x. Okay, we're going to have to move both pieces to this side. So we get x squared minus 2x minus 3 equals 0. X squared plus 2x minus 3 equals 0. Over here, we're going to go ahead and factor that. So negative 3 adds to negative 2. That's going to be x plus 1 and x minus 3, which gives me the answers of x negative 1 and positive 3. Over here, we have a negative 3 but a positive 2, so that's going to be x plus 3, x minus 1, and so we're going to get the opposite of x equals negative 3 and positive 1, which is kind of a mouthful, but that's what we get. All right. Bada bing, bada boom. Number 50. Whew, we still got a couple more to go. My goodness. 4x plus 3y equals 4, and 3x plus y equals negative 2. Now this is a systems of equations. What we could do is we could multiply top and bottom by something and do elimination, or we could do substitution. So I'm going to choose to do elimination. I'm going to multiply this whole thing by a negative 3. And the reason why I'm going to do that is this will cancel that guy out. Okay? So we're going to rewrite this equation as negative 9x minus 3y equals a positive 6. And then I'm going to bring this equation down. We're going to get 4x plus 3y equals 4. I'm going to add these two equations together. This is going to end up with negative 5x. This will cancel, and we'll get 10. X will be negative 2. Once you find x, you can plug it back into any of the equations and solve. I'm going to plug it into this one right here. And we get 3 times negative 2 plus y equals 2. So that's negative 6 plus y equals 2. Add the 6 over, y equals 8. So those are our two answers for that. (51). 9x minus 8 is greater or less than or equal to 7x plus 16. So what we want to do is move our smaller item, so subtract that, becomes 2x, add 8, that's going to become 24, divide by 2, and we get x is less than or equal to 12. We didn't divide by a negative, so I don't have to flip anything. 52. 15 over 2x plus 4 greater than 3x minus 5. Okay, so 15 divided by 2 is not a perfect number. So what I want to do is I want to change this. I'm going to multiply this by top and bottom by 2, so that becomes 2, and that's going to become 6. So now we can combine those terms. This guy's smaller, so I'm going to move him over here. Take 6 away from 15, and I'm going to get 9 over 2x, and move the 4 over here. And that's going to give me a negative 9. And then we're going to get rid of this by multiplying by the reciprocal. And multiply this by the reciprocal. The 9's cancel, and x is greater than a negative 2. I never multiplied or divided by a negative, so I don't flip the sign. 53.
Selena Cruz, please come to the front office. Selena Cruz to the front office.
Okay, so this is a compound one. So when we do compounds, we can, all we have to do is when we add 17, we have to do it to both pieces, which is kind of fun. So you add 17 to 19, you're going to still end up with a negative 2. And when we add 17 to this, we're going to get 51. Then divide by 3. So we get negative 2/3 x and greater than or equal to, so 51 divided by 3, that works. I don't know what it works out to be. 17. That's a compound inequality, which is kind of fun. And we have another compound inequality. Can you believe you did all this last year? Okay, so this compound equality, to get the 3 out of the bottom, we have to multiply by 3 on both sides. So that's negative 9 and 15. Add the 5 to both sides. That's negative 4 and 20. And then divide by 2. And we get negative 2 and 10. Okay, 55. Absolute value of x minus 2 is less than 1. Okay, when you have absolute value, you get in this game called less than or greater than. It basically becomes a compound inequality. So this is less than. So we do 2 problems. So it's kind of like our case 1, case 2. So x minus 2 is less than 1, and x minus 2 is greater than negative 1. Okay. Solve this, we get x is less than 3, and it's less than, so we're going to do and. X is greater than, what is that, 1? If we want, we could write this as a compound inequality. X is And you always do it like this. So x is bigger than 1 but less than 3. And 56, x minus 3 over 2, absolute values is greater than 3 over 2. This is a great OR problem. So we do x minus 3 over 2 is greater than 3 over 2. That's our case 1. And case 2 is x minus 3 over 2 is less than or equal to a negative 3 over 2. So over here we add it over, and we basically are adding 3 to 3, so we get x is greater than or equal to 6 over 2, which is about 3. Or we add that over, and that goes to 0. X is less than or equal to 0. So it's an OR problem, okay? Not an AND problem. Again, that's because it's a great OR problem. Okay. For 57, 58, find the distance, the midpoint, the slope, the equation of the line. That's actually all geometry stuff, so we're going to go ahead and skip those last 57, 58, 59, and 60. I'd still like you to work on them, but we're not going to have a question on that on the test. So if you don't get to those, that's okay. So over and out. We'll see you guys.